Not, not. So, think either today or tomorrow you may receive the mail regarding internship because due to that the pandemic situations, like your senior batch, like a 17 batch, for your 18 batch also we have relaxed few norms for an, that summer internship 2 credit course. So I think today we will send this maybe email to all the students. You can follow the guidelines. Like you can do research paper in any of our faculty, or you can do vital courses. Similarly, you can do online courses. You can do the internship in the industry either in online mode or offline mode. But all these things, that internship online or offline mode only during the summer break, because summer you have break for almost 35 days. During the 35 days, you can do that internship either online or offline. So I think that guidelines we may receive. Maybe today evening or tomorrow we will send. You can make use of that. Similarly, if anyone, if you are willing to do your that is internship as a research paper, so you can approach the faculty members. So
Sir,
yeah,
during the last month's break, there was a
yeah,
break before that you told to do the internship.
yeah.
Sir, I have done the internship during that time. Sir, what is the procedure after that?
You got that bonafide from the
Yes, sir,
department.
company.
Yeah. So now maybe after maybe within next 1 week 10 days we will activate that in a Vita. You have to upload required documents. Then we will conduct an review. We'll fix the panel members. You have to present your findings during the internship. Then based on your presentations and the certificates, other things, your the presentations and the internship will be evaluated. That will be added as a mark for the respective course.
Okay, thank you, sir.
Okay, okay for that. So actually, last class we have seen about switching techniques, various switching techniques like manual switching, then message switching, then circuit switching, and packet switching. So next we will move to the categories of the various networks. So the network categories. Let us assume, take an example of maybe our university. Um, so we are having many labs. We are having many labs. Yeah. So let us consider we are having lab. For example, we are having maybe TT134 our network lab. We take our network lab. Let us consider TT134. It is network lab. We take a network lab. It contains more than 66. I think 60 to 70. It is there in our laboratory. Similarly, if you take other lab, we take wireless communication lab. So TT135. It is containing some 36. Similarly, if you take VLSI lab in the second floor. So I think TT that is a 233 or 30 like that. So it is a VLSI lab. So in our block itself, in a TT block itself, we are having so many laboratories. So each and every laboratory it contains so many systems, so many systems. So we have to establish a network in a individual lab wise to share all that the shared server shared files. For example, if you take now the NetSync, we are accessing from our the Sense desktop, that is a server which is there in SDC. From SDC, they are connecting to our the Sense desktop as a separate server which is there in our the Sense tool. Then from that they are accessing. So we have to connect the systems the locally in a particular lab. Then we have to interconnect all the labs in a TT block. Then we have to connect to the entire network. Let us consider this is the TT block. Similarly, SJT, MGR block. So many blocks. We have to interconnect all the blocks. We have to interconnect all the blocks. Then, to access internet network, all these connections will be connected to the external network. Suppose I want to send a mail from maybe one system from TT134 to outside the world. So I am going to share this to the server to the overall server. Then it will go to the outside through internet network. So depending upon the system interconnection, for example, in a single lab, I want to establish connections with the 60 system. I am connecting this locally, then this is called as lab, local area network. So for a single lab or for a maybe single block with interconnection, then it is called as a local area network. Then one more thing, it is the WAN. So this is nothing but the metropolitan area network. For example, let us consider our V8 is a metropolitan city because it is having around 400 acres. It is like a small city. It is like a small city. So we are going to interconnect. We are going to interconnect all the blocks using the central server to access to share the network. It is like the MAN. So LAN and MAN. We are going to interconnect different MAN. For example, this is one MAN, our VIT university. Let us consider some other things. Suppose here CMC is there. CMC, they're having the different things. So we are going to interconnect all these things through internet. Then this is nothing but wide area. So LAN is nothing but the local group within the computers or within the small block. Man is nothing but it is around maybe 1 kilometer or 2 kilometers like this with a certain number of systems. The WAN is nothing but the wide area network that is for an entire world. So depending upon the application, depending upon the configuration, depending upon number of systems interconnected, depending upon the radius of that network, we can categorize LAN, WAN, MAN as a different network categories. So a LAN, it is a group of computers connected in a small geographical area such as a residence, school, laboratories, university. It is small. Maybe one block, we are having one block, we are going to connect all these. Then that is nothing but a LAN. So the WAN, it is nothing but it is nothing but the combination of the different the LAN. Then MAN is nothing but interconnecting users with the compute resources. So MAN connects an area larger than LAN but smaller than WAN. It is like for a single campus. We are having more number of systems. We are going to connect all using the single network. That is nothing but the MAN. So metropolitan area network. It is it is a little bit larger than LAN. It is smaller than the WAN. So depending upon the applications, number of the system interconnections area, you can divide any categories of network into the LAN, WAN, and MAN. See here. So this is nothing but individual LAN. We are going to connect individual LAN using the MAN. Then we are going to interconnect all this MAN to the rest of the world using the WAN, using the wide area network. So this is nothing but the categories of the network. Then one more category we can divide, we can classify into peer-to-peer network, client server network. Suppose, for example, maybe in a home like that. So we are having two systems. Let us consider in a home we are going to two. So this may be used by yourself. Maybe this is nothing but node one. Another one is used by somebody, maybe your brother. So you can share, you can create the work group home as a network. You can exchange information between N1 to N2. This is nothing but one-to-one communication or peer-to-peer network. We see here in the peer-to-peer network, there won't be any master, there won't be, that means there won't be any server, there won't be any client. But if you take any laboratories, even if we take our network laboratory, we are having NetSim server. So all that remaining systems, client, they are accessing through a network, through LAN, to the NetSim is there in the server. So the server will like a master. Server will have a full control over the client. So the client, it is nothing but anything it required, it will send the request to the server. Then server will grant the access for the further thing. So depending upon the type of access, we can divide network as a peer-to-peer network or client-server network. So peer-to-peer, it is an one-to-one. It is nothing but small windows per group, one per group. So client server, it is nothing but the like a lab. For example, mail server, web server, all these is the client server. So depending upon the size, depending upon the access, you can divide the network into LAN, WAN, MAN, peer-to-peer client server network. So, what are the things required to build a compute network? You need computer peripherals. You need a network interface card, that is the Ethernet card, which is used to connect you with the respective. And you need the connecting media cable like that. You need various network devices, routers, switches, bridges, hubs. Then you need the software. You need the protocols. That is a set of rules. A set of rules that will be common to all entities. Common to all. So to establish any compute network, you need computer peripherals. You need the network interface card. You need the connecting cable media, then you need different networking devices, then you need that OS software, then you need set of standard procedure, that is the protocol. So these are all the basic elements which is required to build any computer network. So we have seen about the various categories of network. So as of now, we have seen about evolution of network, evolution of switching techniques, then various categories of the respective the network. So next, we are told the protocols, the set of the communication tools that all entities must agree on it. Protocol. So similarly, even starting itself, we are told. So any complex work can be divided into small work. So that is called as layer. So each and every layer is having different functions. I think we have seen the last class. So next we'll see about the open system interconnect. That is the OSI a layer for a network. That is approved by the ISO Intra-System Organization. That is an it is an the body which is used to given the standard for anything. Standard for anything. So next we'll go for that OSI model. OSI layer model. So that ISO, International Standard Organization, is responsible for wide range of standards. That is the fixing standards. Even if you see that many industry, they have ISO certifications. It is an organization which will fix a standard for process. Process. It may be anything. It may be anything. It may be institute or it may be organization or it may be any other networking. So it fixes some standard, the rules, standard things for any process. Any process. In 1984, the Open Systems Interconnections a reference model was approved by ISO as an architecture for a compute network. Before that, TCP/IP has been established. The TCP/IP we will see in the next class. This is the first, the respective the network model. After that, OSI came into picture. So first we will see about OSI, then we will move to the TCP/IP during next class. So this it is nothing but the normal the postage because even in a computer network also this is the sender system. This is nothing but the source or sender. This is nothing but a destination or receiving system. I am going to send the message information from sender to receiver. It is like a normal the courier or post box. Suppose if I want to send any letter, I have to write the letter. Then I have to put on the envelope. Then I have to paste the envelope. Then I have to write the from and to address on the envelope. Then I have to put on the post box. Then the respective from the post box it will go to the respective the post the the respective the stations, that is a post office. From there, it will go to the central post office. It will go to again that the receiving post office. Then it will does the reverse operation. It is nothing but the standard set of procedure to send and post letter from the sender to the receiver. So if you say that the sender, the letter is written, put in an envelope and drop in the mailbox. The letter is carried from the mailbox to the post office. The letter is delivered to carried by a post office. We'll go to here. The letter is delivered from the carrier to the post office. The letter is carried from post office to the mailbox. Then that will dispatch to the receiver. The letter is picked up, removed from the envelope and read. So you can divide normal, that letter communications in terms of the three processes. One is nothing but the carrying the letter from others one, that is the sender to receiver. Next is nothing but it is nothing but from the respective or the mailbox into the post office carrying that. The upper it is nothing but that related with the end users. Writing letter, put on the envelope, then write the to and from and to address, then post it on that drop on the mailbox. All these things it is done by the respective the end users. So you can divide the process of that letter sending into the three items. One is nothing but a higher layer that is directly involved with the users, end user. Middle layer it is nothing but the few operations it will be carried from end users to the respective the transport. That lower it is nothing but an one-to-one transfer. Similarly, in a network also, you can divide the entire process into the three. Higher layer that is directly involved or related with the applications or end user or and systems. Then middle layer, it does some operations between end users to the respective the port. Then lower, it is nothing but a physical medium which is used to send the information. So you can relate the same thing like a letter transmission to the respective the computer communications by set of the three different sets. So before going to the next one, we will see one that animate video. If you are seeing that, I think that you will have an understanding about the network, the layers. Can you able to see this?
Yes, sir.
Okay, thank you.
Sir, we are not able to hear it. We can see it actually.
Yeah, just a minute. Yes, you are not able to hear it.
So we're not able to hear it, sir.
Okay. I think just a minute. I will remove this headphone. Okay.
Now is it okay?
No, sir, we are not able to hear it.
Okay.
Sure, while sharing the screen, you need to share the audio
Yes,
also.
yes. Yes.
So while sharing the screen, you also need to share the audio.
Set the audio where?
So while sharing the screen, you also need to
Okay.
share the audio.
Okay, okay. Now is it audible? Now is it audible?
No, sir.
No, sir.
Where I have to share the audio?
So on the share screen, when you press the share screen, there is a slider on top, so which says share audio. I believe that's what you did.
Share screen?
So when you press the share screen button in Teams, so I
Okay.
believe there a small slider comes up in the top left, I believe, which says share audio. If I'm not mistaken. There's a slider there.
Input computer sound, I think. Yeah, I think now I think.
Yeah.
Yes, sir.
Now?
Yes, it's audible.
Oh,
Yes,
okay.
sir. Now it's audible.
Yeah, okay, but okay, but thank you.
The digital revolution has changed the way we work and communicate almost beyond recognition. Yet the smart, interconnected world we live in is still neither as smart nor as connected as we would like it to be. Until in the mid-1980s, the ISO, or International Standard Organization, developed a networking model to provide standards that will become the basis for network designs. This is the OSI model. 7 layers build up the Open Systems Interconnection, or OSI model. Let's take the flow of data and represent it with a train system. Sending a file or clicking a link in your computer ignites a flow of information. The first layer to receive the command is the application layer.
Here, that the layer 7, it is an application layer. It is directly, relate with the end users. Like in a train system, suppose if you want to set any packages. So, we are approaching the respective railway stations. We want to suppose all the parcels, we are putting on that respective railway stations. They will convert that as a package because it is related with our the end users applications. Then that will be carried on the train.
The application layer serves as the window for the users and application processes to access the network services. This layer contains a variety of commonly needed functions, like resource sharing and device. Data are packed and ready to take on a long journey. After the data is read, the next layer, or the presentation layer, formats the data to be presented to the application layer. It can be viewed as the translator for the network. This layer will translate data from a format used by the application layer into a common format at the sending station. It then translates the common format to a format known.
Next layer, it is another presentation layer. So here you know that the raw data, here they are converting that into the presentable form. Suppose for example, in a train we are having the goods, we are having many compartments, many things. If the weight or even that the upper bottom, it is not in the equal uniformity. So this layer will distribute and then will convert that into the presentable form. So the layer 6, it is nothing but a presentation layer.
To the receiving station. The presentation layer also encrypts control information into the data, in this case, the train, to be read by the next layers.
After each and every process, each layer will append the respective the header information, because you know that process was over here. If you see that in a normal letter writing, once you are completing letter writing, we are going to put on the envelope like this. Here, you know, the presentation layer will add the few that header information. That is, the process was over in the presentation layer. We indicate that.
This layer allows session establishment, maintenance, and termination, which allow two application processes on different machines to establish, use, and terminate a connection, called a session. This session support, which performs the functions that allow these processes to communicate over the network, performing security, name recognition, logging, and so on. This
Session layer, which is used to ensure the security, that is encapsulations take care in a session layer. It will use to ensure the security. Then after this session layer, then it will connect to the transport layer, because you know once we are going to collect the information from the end users in application layer, then we are going to convert that into the presentable form in the presentation layer. The session layer, which is used to ensure the security of all these things, it will use to identify which the destination address where we are going to transport. So after these things, after these three layers, next it will pass to the middle layers. Middle again, it contains the next two layers, that is a transport layer and other layers.
After another journey, the data passed through a layer of security and validity. Are encapsulated into packets. Routing takes place in this layer where the path pyramid.
Next to the transport, it is the network layer. Here, if you see that the information has been divided into the small the packets. If you see here, input, it is a single. Output, if you see it contains the many compartments. So the network layer here, all the IP address will be assigned here. because here only we are from transport plus network layer, you are going to identify destination address. So based on destination address, that is IP address, it is dividing the packets, then it is carrying to next lower layers.
The data link layer. The packets are turned into frames for the specific networks. The data link layer provides error-free transfer of data frames from one node to another over the physical layer.
Data link layer, the packets has been transferred to depths of the frames,
allowing layers above it to assume virtually error-free transmissions over the link. A switch in networking takes place in this layer, where packets are read of its control information and then encoded with the media access control or MAC address. The MAC address contains 12 hexadecimal digits and prevents collision in the The physical layer transforms the frames into bits, and then sent over the network via physical hardware or media. In this case,
you see
the
here the
Ethernet.
frames has been transferred into the bits, that is a physical layer for physical transmission through the required media.
Data are logically arranged and encoded before they get sent to a physical media to another computer, and is then received by another computer's physical layer.
So on the receiving side, it does an inverse operations.
Some data or information in the upper layers are destined to be sent through the Internet, a vast interconnection of information and data. Either way, the data sent will then be received by the 7 layers of another computer, from the physical layer, which encodes the bits, back to the data link layer, where the bits become frames and is transferred error-free, to the network layer, where frames turn back into packets and then sent to the upper layers, into the transport layer, where validation and firewalls take place, sent up to the session layer, where connections called sessions are maintained or terminated, back to the presentation layer, where the data are turned back into a format that can be read by the presentation layer, and finally, sent and presented to the user via the application layer, where you will be provided with your request or command.
I think we have seen about the animated video about the various layers. Then the functions of each and every layer we will see in the next class.